Okay, guys, I think we can start right now. So today's workshop is going to be, as you can read in the message from Julia, it's going to be focused on oracles. Of course, you already know a lot of things about oracles, but the purpose of these workshops is having like a list of checks that we should take in consideration when having an audit from a client which is implementing this type of features, in this case oracles. But in the last workshop was about lending and borrowing, and after the workshop I provided to you like the list of checks that I would take in consideration in every protocol about lending and borrowing. So when you get an audit from a client, you can directly dive into this list and start performing these checks without having the necessity of having all the checks in your mind. You have the list and you go one by one checking these things, and then you can move on and start checking the logic which is unique from each protocol. So in this case, we are going to be analyzing oracles and the security features or security checks that should be performed by each of us when we receive an oracle. As I mentioned, this is going to be focused on the common things that can be found within several protocols that are implement oracles. Of course, each protocol is going to have their own unique logic, so you should be analyzing more than just being checking the list and stopping stopping after the list. Of course, each oracle is going to be having its own logic and unique bugs or vulnerabilities related to this logic. So, of course, you already know oracles, but let me give to you a little presentation. Oracles is basically well, before talking about oracles, one of the main problems in smart contracts and blockchain is the way of retrieving data which is not on chain. So this is a critical point because the data which is off chain or which is not within our smart contract can get manipulated or can be fake data. So this is a critical point because, as you may know, everything on chain follows the logic and cannot be modified or perform some things that are unexpected, only if you have vulnerabilities or things that you don't control. But introducing data which is not on chain or which is not within our smart contract, this means that the data source is not under our control or under a distributed network can introduce serious risks, which is the manipulation of data and having data which is not correct, intended or not intended. The reason is not our concern, but the consequence is. So let me share my screen and I'll show what I have prepared for you. Okay, here we have. Can you see my screen, right? Yeah, I think so. Well, first of all, we need to differentiate between the trust and recommended oracles to be used in our smart contract and something which is something that you already know, which is retrieving on spot prices, for example, from pools, or not always from pools. For example, to a centralized oracle, which would be another not recommended option because having a centralized oracle means that the owner of the oracle is the one having the whole control and the whole power of how the data is going to be introduced to our system, to our smart contract. So, of course, you already know that spot prices are not a good source of data because they can get manipulated, but it's something to take in consideration because there are a lot of developers that are still implement this type of checks. And something to mention here is I have been finding or receiving protocols or seeing in in Twitter or in any other site developers implementing, like, they know that spot prices can be manipulated, so they first implement a check within the smart contract to check if the spot price is manipulated or not. But the key point is that this check can also be manipulated. So this is not a good option, and this checks is not going to be protecting the system and the smart contract of having a hack because of Oracle manipulation, in this case, the spot price. So in order to solve this problem, we should be using a trust Oracle. Or when I say trust, it's not that you are trusting a single entity to perform good, but when I say trust, I mean the most used oracles, which are Chainlink, Pyth, and the 10-weight average oracle the 10-weight average price oracle. So most of the time, the majority of the protocols implement Chainlinks, Chainlink oracle and Pyth feeds, and some others, Pyth and the TWAP. In this case, we are going to be analyzing Chainlink and Pyth. You may already have audited a lot of protocols that implement Chainlink, but as I said, we're going to be seeing or having a list of checks to be checked when we receive an audit which is implemented Chainlink. And of course, we are also checking the safety checks that should be introduced when using Pyth or Pyth, which is not as common as Chainlink. So you may have some key points here. The TWAP oracle is not going to be analyzing in depth here because this will be a really large workshop. So maybe in the future we can execute or we can perform a workshop only focused on TWAP. But today we're focusing on Chainlink and Pyth. So basically, the difference, Chainlink and Pyth has several differences, but clients normally, or developers normally choose between these two just because they may know better how to implement Chainlink, or they may know how Pyth works. So the selection basically depends on how comfortable they are with each of these two. But they have some intrinsic differences. So here we have a table which is it's a really good one to check the differences because of how they function. Here we can check that the type of how Chainlink is. Chainlink is a decentralized Oracle network. That means that the resulting price, which is published to the price feeds, is what comes from several different sources which are decentralized. This means that the manipulation is not easy, like it was in spot prices. Now we have the TWAP, which is an on-chain price average method. This basically says how it works, which is basically performing the average price from a selected time period. Then we also have Pyth, which is a high-performance Oracle network, which is something similar to Chainlink, but they have some differences that we are going to mention later. So how the data is taken for each of these oracles? Well, for Chainlink, the data is taken off-chain, and then it's aggregated from these data providers. The TWAP, the data is directly taken on-chain, fetching the prices from decentralized exchanges, DEXs, and pools. Let's say that if the TWAP period is really short. I mean, you don't take a long enough period, you take a really short period, the intrinsic behavior can be the same as spot price. If you take the period in a one single step instead of having a wider length in time. So it's really important to select the time frame for the TWAP long enough to not be manipulated. As I said, we are not going to get really deep in TWAP, but in the future we can do a workshop about TWAP. But if you are curious, you can also check Uniswap docs, which is they have a really good article about talking about how TWAP works, and yeah, they also have some example of how many funds would you need to manipulate the TWAP depending on the time frame that you are choosing. And also we have the Pyth, which its sources of data are owned off-chain, which are directly from exchanges and market makers. And this data, which is are computed off-chain, is later introduced on-chain by executing certain functions directly by each of the users. These have a really interesting behavior, which I'm gonna be presenting later. And also we have the how this how the data is delivered in Chainlink and TWAP. The data is pool based. When you wanna get the price, you basically execute a read function to be getting the price from these two oracles. But instead, in the Pyth case, the data is pushed because it is generated off chain by certain networks and the wormhole bridge, and then users are basically pushing this data, which is given from this source of data just mentioned, and introducing this on-chain. This is the reason because it was labeled as push-based oracle. And then we also have a table which is basically differentiating the security aspects between each of these oracles. So regarding manipulation resistance, Chainlink is really high because, as I said, I also already mentioned how a little bit it works. Basically, the data is computed off-chain, and then it comes from a decentralized network. So you wanna manipulate the prices, you have to manipulate most of the nodes of this network, which is not something really easy. Then the TWAP depends on different things. For example, the liquidity of the exchange, of the central exchange that we are getting the data from, or the time frame as I just mentioned. So you get this central exchange which has a long amount of funds and liquidity, and you select the long enough time frame, the manipulation would be almost impossible, or it will cost you like several million of dollars, which is something not feasible for attackers because they will not get their incentive for manipulating the TWAP. And then we also have the Pyth, which the manipulation resistance is really high because it takes the data from trusted market participants. And regarding this decentralization point, Chainlink is really strong on this because, as I just mentioned, it works like any other decentralized network. It would also depend on how many nodes are operating, but in the case of Chainlink, there are a lot of nodes, so the decentralization is really good and really strong. And regarding TWAP and Pyth, for the case of TWAP, it would depend on the DEX and the centralization of each of the desks, which is implemented a TWAP oracle. For the case of Pyth, the centralization is moderate because there are fewer publishers in comparison to Chainlink, but I would say it's enough because there are also trust parties. And then regarding on-chain attacks, in the case of Chainlink, it is protected because of this off-chain configuration. The TWAP is vulnerable to sandwich and meth attacks, as I just said, depending on the time frame that you select for determining the price of each DEX, and also depends on the liquidity of the DEX or the DEXs. As I mentioned, you want to be checking deeper on how TWAP works. You can read the docs from Uniswap, which directly gives some numeric examples on how many funds would you need to execute an attack, depending on several parameters and several things, which is really interesting. And regarding Pyth, well, it relies on average risk, so that would depend on for example, home to compute how resistant it is to on-chain attacks. Okay, guys. So now that we already have a wider vision on the difference between each oracles, we are going to present some checks for the case of Chainlink and Pyth networks. So in the case you receive an audit from a client, you can be checking these things before diving directly into the business logic of each protocol. So we're going to start with Chainlink. After the words, I'm going to be pushing this repo, so you can have this in your control, and I will also give you. I will create the safety checks list, so you can also have it in and use it when you get some client. So basically, what we have here is a really simple implementation of Chainlink break fees, which is something that I've seen a lot of protocols which they implement this without any safety checks. So what do we have here? Basically, we have an example. Well, this don't take this in consideration because that's a simple example. But we have here the function which is used to retrieve the price and no checks. At least they have been using here the latest round data function, which is the recommended one, but you may also find, I will make a note here so you can check it so later. So you can find some protocols and clients using latest answer. This is something deprecated that was used sometime before, but it's not longer recommended. So that would be a vulnerability using a latest answer. So in this case, always use latest round data. So latest round data is the good function to use here, but it is not enough. You have to validate the answer, and you also have to implement some checks depending on several things. So we are going to be doing these checks here. We have another smart contract which have already implemented these checks. So the checklist contains 11 checks that are going to be mentioned right now. So you get into consideration when you audit or implement Chainlink. So the first one is do not use, as I mentioned, do not use latest answer. Here there's a typo. But in this case, always use latest round data. This is a must. This is something that should be checked every time, and it's the most important point, using latest round data. After that, this is something that that would depend on the business logic, but you as an auditor should be taken in consideration that getting prices from Chainlink may, in some cases, revert. Not because of Chainlink, but maybe there is something wrong. For example, maybe the code is not correctly implemented. So you may give recommendation to the client to use a try catch block. So basically you are checking if the latest round data function is going to be reverting or not. This is not something that you should be implemented every time, because maybe reverting is the expected behavior. But in other cases, I've seen protocols and clients that in the case of revert from Chainlink, they have a backup oracle, so they could be using a secondary oracle, which was implemented in the catch part. Or, for example, they are not performing the call to the oracle, but securing another business logic. As I mentioned, this would depend on the client decision and how the business logic for the protocol is selected. But from your perspective, you should be aware that the call to Chainlink could revert for any reason. We are not focusing on the reasons here, but of the consequences. So it's something to take in consideration and something to be aware of, just to know how to handle and how to recommend the user on the client to perform after that. So in this case, we have implemented a try catch block. This is a really silly example because basically, yeah, I just implemented this for you to be aware of this could happen. But we are having here a primary spread feed and here a secondary, which does not make a lot of sense because that would be retrieving different prices. But it was just an example because I didn't want to implement here the Pyth oracle because we are going to be taking this in a separate module. Okay, so after that, the most important part here as well is the validation of the retrieved or returned data from the oracle. So here we have the checks, which are mandatory from my perspective and should be included in every protocol. So if the client do not execute these checks, I would definitely raise this as a vulnerability. I would strongly recommend the client to perform these checks, because otherwise they could be having the well, they could be thinking that they are retrieving correct prices, but instead they are basically getting prices but which are not correct, which maybe be stale prices or prices from which basically are returning a zero. They think, well, the price could be zero depending on each asset. Of course, if you're retrieving the price from Ether and you get a zero, you won't be thinking that's the correct prices. But Chainlink have spread fees for a lot of assets, not only crypto, but also other things, which could be really close to zero. But in this case, we should be checking, in this case for DeFi, which is the majority of protocols that we get for our team, we should be checking that the answer, which is basically the second parameter returned by the latest round data method, should be greater than zero. Otherwise, the price fee is not working correctly. And also, we should be checking that the updated add parameter, which is the fourth one, is greater than zero. Otherwise, that would mean that the publishing time for the price feed data is not correct. Here you see that this is the try catch block is only checking the call to the latest round data function, but we could implement also the try catch method to check if this revert execute the backup oracle. And there's something really important here as well, which is the stale feed threshold. What this means? Well, for Chainlink, well, as you already know, Chainlink has a lot of price feeds, and the publishing time for each price feed is different. That would mean that would be the heartbeat. So you come to a price feed from Chainlink. You would, for example, here we have selected Bitcoin and USD dollars. You have here the heartbeat, which is the frequency of the time of publishing. So if you don't check how is the publishing time for your price feed, you could be receiving a a really old price if the price fee is not working correctly. So this is a key point and a key check to implement in each call to the Oracle. And something to note here is the heartbeat for each price fee is different. So you could have this price fee which is saying that the heartbeat is really close to half an hour, and you could have another price fee which is his heartbeat is its heartbeat is like 10 minutes. So if you have a protocol which is implementing calls for each price fee depending on different assets, you should be having different thresholds for staleness in your protocol. So you are not using the same one for each. The same one for all the price feeds. That would be a vulnerability as well. So this is a really strong check that should be executed for this type of protocols. Okay. After that, you should basically check that the updated add parameter is within the dimension heartbeat or the threshold that you have selected for each price feed. And after that, we should also note to which network or blockchain is the protocol going to be deployed at. Not only at the time of auditing, but also in the future, because if you are deploying your smart contract to a layer 2 blockchain, the price feeds do not work directly exactly as in the layer 1 blockchains, because you would have a sequencer. A sequencer is publishing the prices from the layer 1 to the layer 2, and that's not a. I was gonna say that the publisher, the sequencer is like a bridge, but don't imagine this like a bridge of basically crypto for moving assets from one blockchain to another. But when I say a bridge, I mean a point that can fail, which can fail and not work correctly. So for these cases, we also have an article here. Don't worry, because I'm gonna be sending all the references after that at the end of the day. But you have here an example which is from the Chainlink docs, which basically explains to you how the sequencer uptime feed works for layer 2 blockchains. And you also have here a code example on how to check if the sequencer is up or down, because as I mentioned, the sequencer can be down. And in this case, if the sequencer is down, you will be not getting fresh prices, but still ones. So it's something really important. I also recommend when we have an audit, paste the docs links to the client so they can check directly from the Chainlink data what is this part, if they want a really detailed explanation here. Okay, Shumit, this is cool. Last year I found a bug using these docs regarding the heartbeat. Yeah, exactly. Heartbeat is something really, really, really important. And as I mentioned, I have seen a lot of protocols which just implement this, or maybe implement one check, checking the answer to not be, maybe they implement these checks only to check that the answer is not 0, but they are forgetting about this one, which is really important as well, because the answer could not be 0, but could be a really old answer, and that would be that will result in a really important hack, because you will be using prices that do not represent the current price of an asset. So as I mentioned, here we don't have the example of how to implement the check for the sequencer, but as I said, you have here directly the example. Okay. Some other important things to be considered. One of the most important ones is to never assume that any stablecoin is going to be equal to 1. There have been a lot, well, I would not say a lot, but really important hacks because of this, of a protocol assuming that a stablecoin is always pegged to $1, which is not correct, and that would be something really easy to spot for hackers and to be checking and waiting for exploit this vulnerability, because as you know, every stablecoin is backed for something, by something. That would be reserves or some logarithmic logic, but we cannot assume that the stablecoins are always pegged to 1. I remember 2 years ago, there was a hack in one blockchain to one bridge, and the one of the stablecoin for this blockchain went, I think, was to 0.2 and never got back to $1. So that would be every protocol that has implemented the hard-coded prices to 1 could be spread using this vulnerability. So never assume that a stablecoin is going to be pegged to $1. Another important thing to consider here, which almost any, well, a fewer protocols take in consideration, is the decimals for each price feeds, because most of the price feeds has 8 decimals, but not all of them. Maybe you can be using a price feed which is using 8 decimals, and then in the future Chainlink deploys a new price feed which is not having 8 decimal, and you are updating your smart contract to the new price feed for your protocol, which was audited and created 5 years ago. You don't remember that you have a hard-coded 8 decimals, and you are now using a price feed which is pointed to 10 decimals. So when I audit a code, I am thinking about the current situation and also to the future one, which can lead to strong hacks or problems because of hard coding decimals. So an example could be the most common or most known price feed is the AMPL and the USD one, which you have here. I think this has 10 decimals. Let me get it. No, 18 decimals. We have here 18 decimals. In this case, if you have your protocol hard coded to 8 decimals and then you update your price feed, or you have a protocol which allows creating new markets, for example, which has new assets, and you introduce this asset, and you have also a function introducing new price feeds for these new created markets, to have a vulnerability because of the hard-coded decimal. So I will always recommend using the decimal function, because it's really simple to implement. I would save you a lot of headache and future problems. If you know how to get the decimal from a price feed, it's really simple. You come here to the price feed from Chainlink. You can, to this part, you have this directly contract address, and you can click here and basically come to the contract and read the decimals method that I just said. Here we also have 8 decimals. Okay, and some things more to mention. Okay, I have already mentioned this one, but you could also give the client the recommendation or the idea that they can be using a backup oracle. As I just said, well, as I mentioned earlier before, you could be using Chainlink as your primary oracle and Pyth as your secondary, or in the reverse order. And just for finishing with Chainlink, another important check or thing to take in consideration is not using the native price feeds for rapid tokens. I mean, you have a rapid BTC Rapid Ethereum do not use the BTC Bitcoin USD price feed, but you should be using the Rapid one because Rapid tokens is the same as stablecoin. You are assuming that they are pegged to the current and real price of the asset that you are wrapping, but that could not be the case. And of course, you should be using the Rapid price feed. And I've seen also protocols that always use the native price feed, which is not correct. That would also be a high vulnerability. So that would be everything for Chainlink. You may have already checked and known prior from this meeting for these checks, but I think it's really important to have them in a document that will share them later to you, so you don't have to be thinking about these checks, but you go through the document and checking of these things. That would gives us a faster method for auditing and also a safer one. And now we come to Pyth, Oracle, which is not as common as Chainlink. So you will also get some good stuff here to consider when auditing. So basically, what do we have about Pyth Oracle? Well, the most important difference from Chainlink is what we just mentioned at the starting point of the workshop. Basically, well, in this case, Chainlink was a pull-based delivery mechanism Oracle, and Pyth is a push-based. What does it mean? This means that Pyth is not actively pushing updating the prices, but instead the prices, how Pyth works, basically they are producing the prices off chain, and they are not pushing actively the prices on chain. So I have one question here. Saxon said, how about Uniswap V3 TWAP, which depends on the calinity of the pools? Last index, calinity caches, and how the observations are stored in a circular array for historical lookup and the US vector due to this. Yep. The TWAP also has some weak points and some things to check. But today we're only focusing on Chainlink and Pyth. We can do another one about TWAP that will require a deeper lookup on this. So as I said, basically the Pyth Oracle is performing well, they are taking the prices off chain and they are not pushing them to the chain until one user get the price and pushes it. As you can see here, we have the function which is used to update prices. You can see here we are updating the price, not getting the price. And this function is external payable. So anyone can come here and push a price to Pyth. Of course, you should be paying the fee. The Pyth Oracle consumes some fee to get the prices updated. And for taking the current fee that should be paid, you also could be using this method, which is given by Pyth as well. So you should be thinking here that there could be a critical vulnerability, which is if this is external, anyone could be pushing any price. So you could be manipulating the price for Pyth. That's the common sense logic that you should be thinking, but that's not possible because this update price feeds function and some other function from Pyth is checking if the data which is pushed by the user is correct, legit or not. How this is checked? Well, as we mentioned when we were looking at the tables, the prices from Pyth are generated off chain by some trust authorities, and these prices are basically signed by these authorities. So when the prices are pushed here, the function from Pyth checks if the push price is if it is a price which was previously signed by a trust authority. So you could be executing this with a data that you have created, trying to manipulate the oracle, and the price would not be taken in consideration, but the function will get reverted. So basically, that gives you the power to any user to update the price, but only with the legit data. But that will also introduce some safety, well, some risky edge cases, which are gonna be mentioned later. And we also have here the get layers price, which is using the get price unsafe. This is called unsafe because this returns the price of the price feed without sending the checks. This means that the price, well, this function returns the most recent price update in this contract without recency checks. So this means that the function safely returns the price, which could be a price from the past. So you could be getting a price which is not updated. So how do we solve this? We have here a more correct way of retrieving price from Pyth, which is basically you have here you have two different functions, one for updating the price, another for retrieving the price, but they are executed independently. So in order to solve this, the correct form of the more safe form will be when we have the function for getting the latest price, we are obligating the user to update the price within the same transaction. So the price is updated and retrieved atomically within the same transaction. So here we have the update data, which is introduced to the update price function. This function remains the same because we don't have to implement some tests here because update price feeds, which is the internal function from Pyth, is checking if the signature are correct. And we have been also here not longer using the get unsafe price, but Pyth also gives us the opportunity of using get price no older than, which is basically what you are maybe thinking of. Basically, you could introduce the maximum time frame that you want to be getting your price. That would be the stainless threshold. In this case, it's been set to an hour, so you will be getting prices which are up to 1 hour old. So here you have the two main points. We are now getting into this, but you are basically solving the issue of not being the price updated, and as well on the same transaction getting prices which are not older than the designated period. But it's also really important to validate the price, as we were getting from Chainlink and we were doing some safety validation. We should be doing the same for Pyth as well. So in this case, the validation are different because the prices are returned differently from Chainlink. The formats are not the same. Here we have a base price and an exponent. I'm not gonna be getting into that, but you could check the logs of Pyth. But we have 3 key points to check. One of them is checking the price, which I just mentioned as the base. We should be checking that the price is greater than 0. if the price is not is equal to 0, would mean that it's not correct. And also we should be checking how negative or how is the exponent which was returned by the Pyth price feed. In this case, I would recommend checking that the exponents are normally negative. So the most the minimum acceptable one would be negative 18. Something smaller than this would be reversed due to this check. So that would be a auto safety check. And also we have the confidence interval, which is the third parameter returned by the Pyth oracle. Here we have the check that could be implemented to check if this confidence radio is across our limits and across the interval that we want it to be, to not be our own basically our own price. So that would be all for Chainlink and Pyth. As I mentioned, you have here the checks for most or 99.99% of protocols that you are getting. You should be checking these things and then focusing on the business logic of each client and each code base. This does not mean that after checking this, you can basically do not check anything more related to oracles, but at least you have the list. I will be pushing this repo later, and I will create the list that I just followed to Chainlink to check Chainlink checks and things to take in consideration, and also to Pyth. So you can be using this for your audits. But maybe in the future we can do a workshop about TWAP Oracle, which is something really different to these two, and also have some interesting points. So you can ask something if you have any doubts about what we just mentioned, or we can finish, guys. You don't have any questions? Thank you very much. Thank you very much, Sumit. Really appreciate that. Okay, guys, so you don't have questions? Oh, Saxon, I didn't read the message from Saxon. I meant there are not enough observation. Plus, if we look, the window is set too far in the past, and since it is a SQL array, it can DOS. This is a pretty good example for the ideal implementation. Okay, I'll take it. I'll check it later. I'll check it later because that sounds really interesting. Okay, guys. So I don't have any question. We can finish here. Thank you very much for joining, and I hope that helps you on future audits, having the list and saving you time and getting our clients even more safe. So as we are doing in every audit. So goodbye, guys. Hope you have a great day.
Yeah, bye-bye.